I won't dance, don't ask me. I won't dance, don't ask me. I won't dance, madame, with you. My heart won't let my feet do things that they should.
Welcome to the fifth and last of our review videos. In this section, I'm going to need you to be able to solve inequalities involving absolute values and quadratic polynomials. So let's begin with our first problem. I'd like you to try to come up with a way to describe all the x values that will fit this equation. The absolute value of x minus 4 less than 8. Now, there's several ways you can do this, and there's several ways you can express your answer. I'd like you to see what you remember. Please pause the video now until your work is complete. I have a simple way I use to solve absolute value equations. I write it twice, one with a negative 1 in front and one without. Then I solve each one of those inequalities. In this case, it looks like x is going to be every number greater than negative 4. So, let's see, and all the numbers that are less than 12. If I mark that on my number line, that would be all the numbers greater than 4, but all the numbers less than 12. And so to be the intersection of those two sets. All right. It would be a really good idea if I were to check this. So first, I'm going to write this. And let's see, two numbers. I need two numbers inside, or a number inside that pink area. How about 0? 0 always seems to, 0 works. How about 0 minus 4? The absolute value is less than 8. 0 minus 4 would be negative 4, but that's the absolute value. And so there's one check that works. I'd like to check that on my graphing calculator. Let's see, the part of the graph of the absolute value of x minus 4 I've marked in green that's below y equals 8. And it looks like that part of the graph that's below, that's less than 8, would be between negative 4 and 12. So written as an, it would be this red section I've marked here. And written as an interval, the solution would be all the points between negative 4 and 12, but not including negative 4 or 12. The next inequality, absolute value problem I'd like you to try and solve is here. It has one little additional move in it, and involves the second negative 1. Please pause the video now until your work is complete. So, as you no doubt remember, the only trick here is I'm going to add 2 to both sides of this thing first. Get the absolute value alone on the left. I'm going to rewrite it first by multiplying the left by negative 1 and the right, well, by nothing. It looks like my solutions are going to come out, let's see, x is all the numbers that are less than or equal to negative 1, or x is greater than 7 over 3, or 2 1/3. So all the numbers less than negative 1 equal to, and all, oh, I forgot my greater, there we go. So let me just check those. Let me try a number on the left. Let's see, what's in there, negative 2. So if I put negative 2 into this equation, let's see if it checks. Absolute value was 8 minus 2 is going to get me 6 is greater than or equal to 3. Let me try a number on the right side there. How about 3 is bigger than 2 1/3. And let's see, yes, 7 minus 2, and that's going to get me, and that one checks also. It looks like my graphing calculator backs up my work. There's the part of the function that's above 3. And I'm looking for all the function that's above 3. And in the pink, I'm going to mark the interval, but it looks like I'm going to have to use the union notation. So all the way from negative infinity to the negative 1, including negative 1, the union of that set, and 7/3 up to infinity. One more absolute value inequality equation, just to make sure you got it. Remember how important it is for you to check whatever you think your final answer is. Please pause the video now until your work is complete, and then start again to see if I agree with you. So I'm going to solve this one exactly the way I solved the first two. I'm going to multiply the inequality portion by -1, and then in my second column keep it the same. Let's see, according to my work, all the numbers greater than or equal to 1, and any value of x that's less than -4. So on my number line, that looks like, let's see, all the numbers bigger than 1, including 1, all the numbers less than -4. So I'm all set. I would like to check those, so I'm going to check a number inside the area in the left. Let's see, how about rather in the right, how about a 2? 4 plus 7 is less. Right, now that one didn't check. Let me try one on the left here. Maybe I made a little algebraic mistake. Try -5. And let's see, plus 3. And 7 is not less than -5. I think I might have a problem. On my graphing calculator, this is the graph of the function, and you'll notice the horizontal line below it, -5. There is no point where this function is less than -5. Our next inequality problem is going to be a quadratic. I'd like you to do your best, come up with a solution, pause the video now, and restart it when you're done working. In order to solve the quadratic inequality, what we do is begin by solving the corresponding quadratic equation. And you can see the two solutions we got are -3 and a +4. If we look at the graph, here's the portion of the function that's above 0, greater than 0. The green will mark the area, all the x's that are less than a -3 and greater than 4. So our solution is the union of these two sets. I have one more problem I'd like you to try. It's a quadratic. It's a little, just slightly more challenging. Remember, solve it like the equivalent quadratic equation first. Pause the video now until your work is done. So in order to solve this inequality, what I'm going to do is try to solve the equivalent quadratic equation. Subtract 20 from both sides. In this case, I'm going to factor it. I'm going to get 2x minus 5 and x plus 4, which means the two solutions for my quadratic will be 5/2 and a -4. All right, I'm going to look at this on the graph. So the parabola is the portion on the left, 2x squared plus 3x. The horizontal line is the portion on the right side of the inequality, y equals 20. I'm looking for the portion of the parabola that's less than 20, and that would be all of this. Now, what are the x values that encompasses? It looks like, straight down from the left, it looks like that's -4, and straight down from the right, it turns out to be 5/2. So this area in green is going to be the solution to my quadratic, the original problem. All the numbers from -4 all the way up to 5/2, including, that's why the square brackets, -4 and 5 over 2. In these 5 problems, I was hoping to demonstrate to you a variety of techniques and a variety of obstacles that are going to come your way. What I need you to be able to do now, though, is to solve any inequality either algebraically and or graphically. Thank you for your time and attention.
I know that music leads the way to romance.